Beth Rosengrant, video number 5. Lisa says that a combination lock should be really called a permutation lock. Is she correct? Yes. Lisa, you are correct, because a permutation is an ordered combination. So a combination lock contradicts what the actual combination lock is. This permutation is an act of arranging the numbers of a set into a sequence or order. So when they say combination lock, combination is just a combination of numbers, and then order doesn't matter. So you're right. So if we were going to rename it, we would rename it a permutation lock. And that makes sense because order does matter. If we do care of the orders, that becomes permutation lock. You can't just call it a combination lock. You're right, but the world isn't always right. But we understand it a little fully. The word certain. A student is arguing that nothing in life is certain and proposes a different category, almost certain. I would answer the child that math vocabulary is different than English language. Not English language, just English. Math vocabulary is different than English. The definition of certain in math vocabulary is different than the definition of certain in English. And so if he's saying that nothing is certain, we should be calling it something else. But here's a quote that I found, and I think because Dieter's a little older, so he's thinking a little bit out of the box. I found a quote by Einstein that says, and listen carefully to me, students, so you can follow this. I'll read it a couple times. As far as laws of mathematics refer to reality, they are not certain. And as far as they are certain, they don't refer to reality. So hear that one again. As far as laws of mathematics refer to reality, they're not certain. And as far as they are certain, they don't refer to reality. So that the interpretation, if you listen to it and break it up into pieces, is the laws of mathematics, as far as the laws of mathematics referring to reality, they're not certain. Reality and mathematics are not the same. And as far as they are certain, they don't refer to reality. So when we're talking about certain, we're talking about in math, not in reality. I hope that makes sense. Because we know that math vocabulary is different. And I do understand how you would think that nothing in life is certain. The next question is, there are 3 red and 5 blue bags, 3 red and 5 blue beads in a bag. A bead is picked out at random. Cassidy says the probability will be red is 3/5, but Basil argues it is 3/8. Basil is correct because he or she is stating the fraction of probability, 3/8. They have a 3/8 chance that they're going to get red, because 3 plus 5 is 8. So there are 8 beads in the bag. So you have 8 chances to get a red. Cassidy is referring to the ratio, not the probability. You have to look at the sample space. You have to look at that this is a random event. So Cassidy didn't look at the sample space. She looked at the ratio. The next one is to describe an event that has an approximate probability marked by the letter on the probability line. I'm going to try to put it in the screen so you can see a little better, but I went ahead and described it for you. So we look at A, and A is 0, which means impossible. We know it's defined as impossible. I said that it's impossible that a horse will grow a unicorn horn. B is sometimes. Sometimes it rains when the sun is out. C looks like it's right in the middle between A and E, and I said it's equally likely to pick a red card out of the deck of playing cards. D, it is likely it will snow in January. E is 1, and that is the certain on the probability line. And I said it's certain Christmas is on December 25th. If you look at F, F is outside of the probability range. Probability is from 0 to 1. More than 1 is undefined. It doesn't fit into there. I think think that's it. I hope I did okay.